Hello everybody, this is the chemistry exam review worksheet for grade 8 semester 3 at the International School of Innovation. Let's start by some notes you have to study about chemical reaction. So a chemical reaction is a transformation during which reactants disappear and new products of different nature they appear. What are the signs that tell you whether a chemical reaction occurs or not? Here is some of these signs. 1. We have color change. 2. Gas release. 3. Formation of precipitate. And 4. Release or absorption of heat. So we have 4 main signs of a chemical reaction: color change, the change of color, the release of gas, the formation of precipitate, and the release or absorption of heat. A reaction that occurs with heat release, meaning that we have an increase in the temperature. This reaction is called an exothermic reaction, while a reaction that occurs with heat absorption, meaning that we have decrease in temperature, this reaction is called endothermic reaction. A reaction that occurs without heat exchange, neither heat release or heat absorption, this is called athermic. So we have three types of reactions according to heat transfer or heat exchange. First one is called exothermic. Whenever we have heat release, meaning that increase in temperature, it's called exothermic. A reaction that occurs with heat absorption, meaning that we have decrease in the temperature, this is called endothermic. And the reaction that occurs without increase or decrease in the temperature or release or absorption of heat, this is called athermic reaction. A reaction is spontaneous reaction. One, if it doesn't require any input from the outer conditions, from the outside. While a reaction is called a non-spontaneous reaction, meaning that this reaction occurs after the input of some heat, light, electricity, and other different conditions or different chemicals. This is called a non-spontaneous reaction. Chemical equation. Be careful here in the chemical reaction, in the chemical equation, you have to be careful for the law of Lavoisier. What is this law? Nothing is created, nothing is destroyed, all is transformed, which means that there is an equal amount of matter before and after the chemical reaction. This explains this equation. Mass of the reactants is equal to the mass of the products, meaning that the mass of matter before the chemical reaction is equal to the mass of the products after the chemical reaction. This one, you have to use it in any question talking about the mass of products or the mass of the reactants. You have to mention this law, then you have to write this equation and you can solve. Let's start here with the questions. Question number 1. Classify the following changes as chemical or physical changes. Chemical changes involve the change of the state of the substance and involve the change of the identity. While the physical, it doesn't involve the change in the identity of the substance. Our nail undergoes corrosion. This is sure a chemical change. Digestion of food involves some enzymes, some chemicals which digest food into small pieces and then they go and be other form. So this is a chemical change. Explosion of fireworks, also this is a chemical. Oh my god, all of them, they are chemical changes. Frying an egg. Frying an egg is a reaction where an egg becomes other than the raw material or the raw egg. So also this is a chemical. Burning a paper. Burning a paper and change to be other form of a paper, it will burn and become somehow other form of paper, so it's a chemical. Grinding sugar. Whenever we grind sugar, for example, we have sugar in the form of cubes. If we grind sugar, so sugar will become a normal sugar. It's a grinded one, not a cubic one, so it's a physical without a change in the identity. Moving to question number 2. This is a very important question. So this is a very important question representing chemical reactions. Write the balanced chemical equations for these. First, you have to write the chemical equation and you have to balance it. Sodium bicarbonate, which is NaHCO3. Sodium carbonate, sodium it's Na plus. Carbonate, it's CO3 2 minus. So Na plus CO3 2 minus is going to give us Na2CO3 plus carbon dioxide gas CO2 plus water, which is H2O. Then we have to balance this equation. Okay, how to balance this? We're going to know how to balance this. Na, how many sodiums do we have? Here we have 1, here we have 2, so we have to multiply this by 2. Here we have 2Na, 2Na. How many carbons do we have? This is 2 carbons, this 2 is multiplied by this, so this is 2 carbons, and here we have 1 and 2, so carbon is balanced. Moving to hydrogen, how many hydrogens do we have? This is 2 times 1, it's 2, and here we have 2, so hydrogen is balanced. Moving finally to oxygen. Oxygen, how many oxygens do we have? 2 times 3, it's 6 in the reactants. In the products, we have 3, here is 3, and here we have 2, it's 5, and here we have 1, it's 6, so this is a balanced one. Iron plus oxygen gives ferric oxide. Ferric, it's Fe3 plus, and oxide, it's O2 minus, so it's going to be Fe2O3. And here we have iron, it's Fe plus oxygen, it's O2. Let's balance this. Here we have Fe1, here we have 2 Fe. Okay, here we have 2 Fe, here we have 2 oxygen, here we have 3. Let's start first times 2, so 2 Fe. Here we have 3, so I have to multiply this by 3 over 2. This is done, this is correct, but I can remove the fraction by multiplying this equation by 2. So 2 times 2 gonna be 4 Fe plus 3 over 2 times 2, it's 3O2, giving 2 Fe2O3. If I keep it like this, it's correct. If I complete it like this, it's correct. I prefer to do this one to remove the fraction. Moving to ferrous nitrate. Nitrate NO3 2 minus. So Fe ferrous nitrate. So the formula is FeNO3 2 plus potassium hydroxide. It's KOH, potassium hydroxide. Give ferrous hydroxide. Ferrous is Fe2 plus, so FeOH2 plus potassium nitrate KNO3. K plus NO3 minus. So here NO3 minus, you can Fe2 plus, so by crossover technique you can put FeNO3 2. Now we get move to balancing the chemical equation. Okay, how many irons do we have? Fe, this is Fe, so Fe is balanced, iron is balanced. NO3, we have 2 of NO3, here we have 2, so we have to multiply the other one here by 2. So we have 2NO3, so 2N6O, 2N6O. KOH, how many K we have? We have 1, here we have 2, so we have multiplied this by 2. How many OH? This is OH, this is 2OH, so this is a balanced equation. Moving to write the word equation that describe each of the following and balance the chemical equation and then balance each. So we have to MgO plus HCl going to give MgCl2 plus H2O. Magnesium oxide plus HCl hydrochloric acid gives MgCl2 magnesium chloride plus water. Let's move to balance this. Mg, it's balanced. Cl2, here we have only one Cl, so I have to multiply this by 2. 2H, this is 2H, this is balance. Oh, here we have 1O, 1O, so this is a balance. Moving to second equation. Na2CO3 plus BaCl2 gives BaCO3 plus NaCl. So Na2CO3 is sodium carbonate plus barium chloride give barium carbonate plus sodium chloride. Na, we have 2 Na, here we have 1, so you have to multiply this by 2. We have carbon, 1 carbon, this is 1 carbon, so this is balanced. Barium, we have 1 barium and we have 1 barium, this is balanced. Cl, we have 2 Cl, here we have 2 Cl, this is balanced. Moving to last to the oxygen, here we have 3O, 3 oxygen, here we have 3 oxygen, so this is a balanced equation. Here we have BaNO3 2 plus H2SO4, which is sulfuric acid, gives barium sulfate plus HNO3. So let's start step by step. HNO3. Barium, we have 1 barium, it's okay. Here we have NO3 2, NO3 2, here we have NO3, only one of these, so we have to multiply this by 2. Hydrogen, 2 hydrogens, 2 hydrogens, sulfur, 1 sulfur, 1 sulfur, oxygen, we have 4, and this is balanced. So this one is balanced. Let's move back to BaNO3 for the word equation. BaNO3 barium nitrate plus sulfuric acid gives barium sulfate plus nitric acid. So let's move here to how did we get the formulas. For example, sodium bicarbonate. Sodium is Na plus. Bicarbonate HCO3 minus. What is the thought here? 1. This charge here also is 1. This is minus. So by cross over, so it's NaHCO3. How did we get the formula of the sodium carbonate? Sodium carbonate. Sodium is Na plus. Carbonate CO3. 2 minus, the charge is 1, the charge is 2, so by cross over, so Na2CO3. How to do the formula of ferric oxide? Ferric oxide, ferric is Fe3 plus, ferric oxide Fe3 plus, oxide O2 minus, so this is 2, and this is 3 by crossover, so it's BF2O3. Ferrous nitrate. Ferrous nitrate. This is ferrous. Ferrous, it's Fe2 plus. Nitrate NO3 minus. Charge here is 2. Charge here is 1. Crossover, so it's Fe 3 brackets NO3 2. Why? What brackets? We have different elements. Okay, so ferrous hydroxide, ferrous is Fe2 plus, your charge is 2, hydroxide OH minus, your charge is 1, by crossover degrees FeOH2 between brackets. Okay, potassium nitrate, potassium it's K plus, nitrate is NO3 minus, 1 charge, so it's KNO3. Okay, this is how we get the formulas. Here I'm going back to the names. MgO composed of magnesium and oxide, so it's magnesium oxide plus HCl hydrochloric acid gives MgCl2 magnesium chloride plus H2O, you know it, it's water. Na2CO3, Na is sodium, CO3 2 minus, mainly it's carbonate, so it's sodium carbonate. BaCl2, Ba2 plus, Cl minus, charge 2, charge is 1, so by crossover it's BaCl2 barium chloride, NaCl sodium chloride. Let's move back to the BaNO3 Ba barium, Ba2 plus gives NO3 minus nitrate, so charge 2, this is charge is 1 by crossover technique, so we're gonna have BaNO3 between brackets 2. H2SO4, you have to know it, it's sulfuric acid gives barium sulfate, potassium O3, nitric acid. You have to know this. Moving back to question number 3. Question number 3, combustion reaction. Combustion reaction. Butane is a hydrocarbon gas of molecular formula C4H10. Butane is a combustible gas used in the gas oven. The combustion of a certain amount of butane produces 22.4 liters of carbon dioxide and gives 22.5 grams of water vapor. Identify the reactants and the products. What are the reactants here? Reactants, they are the butane gas and oxygen gas. Products, part 1. Products, they are the carbon dioxide and water vapor. Part 2, write the Bode equation. Butane gas plus oxygen gives carbon dioxide plus water vapor. Okay, so moving to 3, write the balanced chemical equation. Let's write the chemical equation first. Butane C4H10 plus O2 gives carbon dioxide plus water, which is H2O. Here we have C4H10 plus O2. Here we have C, it's 4. Here we have 1, so we have multiplied this by 4. It's 4 CO2. Here we have hydrogen, we have 10. Here we have 5, so we have to multiply this by 5. Oxygens, here we have 4 times 2, it's 8, plus 5 times 1, 5, so we have 13. Here we have 2, so you have to multiply this by 13 over 2. You can multiply this by 2, and you can complete it like this. All of this you can multiply this by 2, so it's gonna be 2 C4H10 plus 13 over 2 times 2 is 13 O2 gives 8 CO2 plus 10 H2O. 4. Give a test to define the presence of carbon dioxide. You can use simply lime water if it turns out to be turbid, so it's carbon dioxide gas. Moving to question number 4, salt in sea water. Salt in sea water. The salty taste of sea water comes from the sodium ion present in the sea water, which is sea salt component called table salt. A salt is an ion compound formed of ion oppositely charged anions and cations. In total, the electric charge of salt is 0. The table below represents the mass of some salt extracted from seawater in 100 grams of sample of salts. Here we have salt and ACl, sodium chloride, 77.5 grams, magnesium chloride, sodium sulfate, magnesium sulfate, potassium sulfate, calcium carbonate, and MgBr2, magnesium bromide. Transform the above table into a histogram. You have to draw a histogram. Here we have the name of the following salts: NaCl. We said that NaCl is sodium chloride, MgSO4, magnesium sulfate, MgBr2, magnesium bromide. So magnesium chloride, how you get this? Mg plus 2 plus Cl minus. This is we get MgCl2. Here sodium sulfate. Sodium sulfate is Na2SO4. Since we have Na plus SO4 2 minus, so by crossover Na2SO4. Calcium carbonate CaCO3. Magnesium phosphate and aluminum chloride are two salts obtained when aluminum phosphate reacts with magnesium chloride. We have to identify the reactants and the products, and you have to write the balanced chemical equation. Write the balanced equation. First, reactants. What are the reactants here in this question? Reactants, they are aluminum phosphate and magnesium chloride. Products. What are the products? They are magnesium phosphate, they are obtained, and aluminum chloride. Aluminum chloride. These are the two reactants and the two products. You have to write the chemical equations part 5. You have to write the chemical balanced equation. We have aluminium phosphate, Al3 plus, PO4 3 minus, so it's AlPO4 plus. Magnesium chloride, Mg2 plus, Cl minus, so it's MgCl2 gives magnesium phosphate, Mg2 plus, so Mg3PO4 2 plus AlCl3. Let's start with aluminium. Here we have aluminium, we have 1, here we have 1. Moving to phosphate, here we have 2 phosphates, so you have to multiply this by 2, since we have here 2 phosphates. 2 aluminium, so you have to multiply this also by 2. Magnesium, we have 3 magnesiums, so you have to multiply this by 3. Let's see how it happens here. So 2 aluminium, 2 aluminium, it's okay for aluminium. Moving to phosphates, 2 phosphates, 2 phosphates, so phosphates, it's okay. Moving, leave oxygen till the end. Magnesium, Mg3, we have 3 magnesium. Cl, we have 2 times 3, 6, 2 times 3, 6, it's okay. Now we move to oxygen. 2 times 4, it's 8, 2 times 4, it's 8, so this is a balanced chemical equation. So here, how did we get the name magnesium chloride? Magnesium chloride. Magnesium is Mg plus Cl minus. So by crossover, 1 and 1, so 1 here and 1 here, so it's MgCl. Sodium sulfate. Sodium is Na plus. Sulfate, SO4, 2 minus. So 1, this is charge 2. Crossover, gonna be Na2SO4. Calcium carbonate, calcium, Ca2 plus. Okay, CO3, 2 minus, this is 2, and this is 2, by crossover, CaCO3. Here we have, say, aluminium phosphate. How did we get aluminium phosphate as AlPO4? Aluminium phosphate, aluminium is Al3 plus. Okay, phosphate, it's PO4 3 minus. This charge 3 and this is charge 3. By crossover technique, it's gonna get AlPO4. How did we get magnesium chloride? Magnesium, as we said, is Mg2 plus, right? So we can get Mg2 plus Cl minus, so MgCl2. Here we have, sorry, we forgot here, so MgCl2. Okay, so moving back to aluminium chloride. Aluminium, it's Al3 plus. Chloride, it's Cl minus. So Al3 plus, Cl minus, we're gonna get AlCl3, aluminium chloride. Okay, so whenever you have to solve these questions, you have to go back to ions. You have to study ions. If you didn't study ions, you won't solve this. If you didn't study ions, you won't solve any of these questions. So be careful to this. Study these questions at home properly. Practice on these questions. Go back to this exam review. Go back to the exercises in your book, and you will solve this normally. These questions are very important. How to write the chemical equation, how to write the formula, how to identify the reactants and the products, and how to balance the chemical equation was the most important part in this quiz or this exam. So study well, guys. The exam is not hard, it's so easy, and good luck.